Welcome to Chapter 8, Measurement, Lesson 8.8, Optimum Volume and Surface Area. Minimum surface area of a square-based prism with a given volume. To get the volume of a cube, you have to cube the side length, or multiply it by itself 3 times. So, the formula to get one side length from a known volume is to cube root it. After knowing the side length, you can put it into the formula 6x squared, where x is the side length, because all side lengths of a cube are equal. This will give you the minimum surface area for a given volume. Example: Ed wants to make a box in the shape of a square-based prism to hold 729 centimeters cubed of deflated balloons. He wants it to have the least possible surface area so it doesn't take up a lot of space. What dimensions should he make the box? First, determine the volume, which is 729 centimeters cubed. Next, we put it into the formula to get one side length. The side length is equal to the cube root of 729, which is 9. Next, put it into the equation for surface area of a cube. Solve it, and the cube will have a surface area of about 486 centimeters squared. And we just restate our answer. The cube should have a side length of 9 centimeters and a surface area of 486 centimeters squared. Maximum volume of a square-based prism with a given surface area. To get the area of a square, you do one side length squared, and there are 6 sides in a cube, so the surface area of a cube is 6x squared. To get one side length from a known surface area, do the cube root of the surface area divided by 6. Once you get x, which is one side length, cube it and you will get a volume. This is the maximum volume for your given surface area. Example: Margot has 384 centimeters squared of cardboard. She wants to store as many joules as possible if the cardboard is made into a square-based prism. What should the dimensions of her box be? First, determine the amount of cardboard she has, which is 384 centimeters squared. Assuming she uses all the cardboard, let's put it into the formula. We solve it to get 8 as our side length. Now that we know the side length, use it to find the volume. Therefore, the box should be 8 centimeters by 8 centimeters with a volume of 512 centimeters cubed. Minimum surface area of a right cylinder with a given volume. We know that when a cylinder is at its maximum volume, the diameter is equal to the height. If the formula for volume of the cylinder is pi r squared times h, then we can change h to 2r. Next, substitute in the volume and solve for r to get the radius of your cylinder with the minimum surface area for the given volume. The height will be twice the radius. Check your answer by putting it into the volume equation, and then substitute the radius and height into the surface area equation to get the minimum surface area for the given volume. Example: A cylindrical container has a volume of 300 centimeters cubed. What are the dimensions that will give it the minimum surface area? What is the minimum surface area? First, we put the volume into our equation and solve it. Therefore, the radius will equal about 3.6, and we know that the height is equal to the diameter, or twice the radius. So the height should be 2 times 3.6, which equals about 7.3. So the radius equals about 3.6 millimeters, and the height equals about 7.3 millimeters. We can check this by putting it back into the volume equation. We get 299.99 millimeters cubed, which rounds up to 300, the total volume. This is correct. Now, with the same question, we need to find the surface area. We have determined the radius to be about 3.6 millimeters and the height to be about 7.3 millimeters. Next, take the formula for surface area and put in the values for radius and height. Solve, and the surface area comes out to be about 247.7 millimeters squared. Now we can answer the question. The radius equals about 3.6 millimeters, the height equals about 7.3 millimeters, and the minimum surface area is about 247.7 millimeters squared. Maximum volume of a right cylinder with a given surface area. A cylinder is made up of two congruent circles and a rectangle. So, take the usual equation for area of a circle and double it. So we change pi r squared to 2 pi r squared. The width on the top and the bottom of the cylinder is equal to the circumference of one circle. So the equation is 2 pi r times h, which is the height. So the formula for surface area of a cylinder is 2 pi r squared plus 2 pi r h. Now, if we substitute the surface area in, there are still two variables, but we only want one. We already know that the height should equal twice the radius, so we can change the formula to surface area equals 2 pi r squared plus 2 pi r times 2r. Next, substitute in the surface area and solve for r. Once you find r, use it to find the height. Check your answer by putting it into the surface area equation, and your answer is correct if it is equal to the given surface area. Substitute the radius and the height into the volume equation to get the maximum volume for the given surface area. Example. Jeff has a sheet of metal that is 30 meters squared. He wants to make a cylinder using all the metal with the largest possible volume. What should the dimensions and volume of his cylinder be? First, we determine the surface area, which is 30 meters squared. Next, substitute the surface area into the equation and use inverse operations to solve for r, which equals about 1.3. We know that the height is equal to twice the radius, which equals about 2.5. Check this by putting the radius and the height into the surface area equation. This is correct because 30 meters squared is the original surface area given. Now, we can take the measurements we know and put them into the volume formula. We know the radius is about 1.3 meters and the height about 2.5 meters. Use this to find the volume, which equals out to be about 12.6. Therefore, to answer the question, the radius will be about 1.3 meters, the height will be about 2.5 meters, and the volume will be about 12.6 meters cubed. This is the end of the first video, and I have to cut it into two videos because the length is not able to be sent in one video in an email.